Okay, so let's do a limiting reagent question. If 2.54 grams of sodium phosphate is combined with an aqueous solution of 145 milliliters of a 0.866 molar solution of copper 1 nitrate, how much solid product is made? So the first step in doing a problem like this is we have to write out the correct chemical formula of the reactants, predict the products, and balance out the equation. So let's look at sodium phosphate. Again, if you have to review how to write down chemical formulas or balance out equations, please look at my earlier videos. So sodium phosphate. So this is sodium phosphate. And we're told it is a solid. And we will add it to a solution of copper nitrate. Copper 1 nitrate is this. It is an aqueous solution because there is a molar data here given, and we need to predict the products. Again, to predict the products, you have to know that this is going to be a double displacement reaction. Please look at my other videos that concern types of reactions to know that this is a double displacement and not a single displacement reaction. So in a double displacement reaction, you'll have the cations. This cation will now combine with that anion, and this cation will combine with that anion. So the products are going to be sodium nitrate and copper 1 phosphate. Why do we know that it is going to be copper 1 phosphate? Because the copper 1 here, the copper here is a +1 charge, so the copper here must be a +1 charge. Okay, now that we know that this is the chemical formulas for our products, we have to balance out the reaction. So to balance it out, we're going to need 3 here, and we're going to need 3 here. So now our reaction is balanced. But before we can go on, we have to look at our solubility rules because we have to figure out the state of matter of each of our products. Okay, so we're looking at solubility rules. We know that sodium nitrate here is going to be soluble in water because knowing our solubility rules table, all group 1 metal compounds are going to be soluble, so this is going to be an aqueous solution. And also all nitrates are soluble. If we look at this compound here, copper phosphate, and we look at our solubility rules table, we can see that this is not going to be aqueous. It will not dissolve in water. So this is our solid then. So this is going to be our solid. Okay, so now let's put down the data under each of the species. It makes it a nice visual field to do our problem, meaning that let's put our 2.54 grams here because that pertains to sodium phosphate, and we have 145 milliliters of a 0.866 molar solution of copper nitrate. The question is, how much is our solid product? This is our solid here. So the question is, what is the mass of our copper phosphate? So to do the limiting reagent problem, the quickest way to do this then is to turn this into moles, figure out how many moles of this we're going to have, and figure out how many moles of this we're going to have here. That's our first step. So let's do that. So to figure out how many moles of sodium phosphate we have, we take 2.54 grams of sodium phosphate, and to figure out how many moles of sodium phosphate, we're going to have to divide it by its molecular weight, which is 163.94 grams per 1 mole of sodium phosphate. And this will give us 0.015 moles of sodium phosphate. Okay, if this is how many moles of sodium phosphate we have, let's predict how many moles of copper phosphate we're going to have. So we're going to predict how many moles of copper phosphate we're going to make if we had 0.015 moles of sodium phosphate. So we have 0.015 moles of sodium phosphate. We know from our balance equation that for every 1 mole of sodium phosphate, we're going to produce 1 mole of copper phosphate. So basically then we're going to produce 0.015 moles of copper phosphate. So let's keep that in mind. So I wrote that piece of data in red here, that we're going to form 0.015 moles of copper phosphate from our 2.54 grams of sodium phosphate. So next, for comparison, we want to figure out how many moles of copper nitrate is in here. So to do that then, since we know we have 145 milliliters, which is, turn that into liters, so let's turn that into liters of copper nitrate solution. We have the molarity of copper nitrate, so we know that 0.866 moles of copper nitrate is equivalent to 1 liter of copper nitrate. That is the definition of molarity. So by doing this, we'll get how many moles of copper nitrate we have. So this will give us 0.126 moles of copper nitrate. Okay? So let's figure out how many moles of copper phosphate we're going to make from this amount of copper nitrate. So 0.126 moles of copper nitrate. If we have to figure out how many moles of copper phosphate, we know that from the balanced equation, for every 3 moles of copper nitrate, we will make 1 mole of copper phosphate. So this comes out to be 0.0419 moles of copper phosphate. Okay, so let's take a look at this number right here. And I'm going to write this number in blue here at the top. Okay, so I've done a little bit of organizing the data by colors. So from what we have learned so far, 2.54 grams of sodium phosphate will give us 0.015 moles of copper phosphate. Likewise, if we have our copper nitrate solution of 145 milliliters of a 0.866 molar solution, this will produce this much copper phosphate. So which of the 2 reactants will give us the least amount of copper phosphate? Well, obviously 0.041 is a lot less value than 0.015 is a lesser number, a least amount of number of moles of copper phosphate than 0.0419. So that means that this will all get used up. Since this gave the least amount of copper phosphate, this then is our limiting reagent. It will be all used up. Which tells you that then this one then is our excess reagent. We're going to have some of this left over. So the problem was how much of the solid product was made. So we're not there yet. So we now determined that we know we're going to make this amount of copper phosphate. So we need to turn this amount into mass. Okay, so to turn that into mass of copper phosphate, we know we have 0.015 moles of copper phosphate. We need to just multiply it by its molecular weight, just 285.60 grams of copper phosphate for every mole of copper phosphate. And this gives us 4.28 grams of copper phosphate will be produced in this reaction. So this is our answer. Okay, so I've added another question here which teachers like to add on a quiz or an exam. Basically, how much of the excess reagent is left over after the reaction is done? So as before, we have said that the excess reagent is our copper nitrate. So this is our excess reagent. This is our excess reagent. How much of this is left over? Well, the data here is how much we have initially, but how much is left over after we make our 0.015 moles of copper phosphate. So we can do it this way. So we can figure out how many, first of all, we have to figure out how much copper nitrate was used in the reaction. So how much of the excess reagent was used in the reaction. Knowing that we know our amount of product, we can work it out this way. Since we know that 0.015 moles of copper phosphate is going to be produced, we can figure out how many moles of copper nitrate was used to make that. So we know from the balance equation for every 1 mole of copper phosphate, we're going to use up 3 moles of copper nitrate. So if you do this, we know that we're using 0.045 moles of copper nitrate. This is what's going to be used. This is how much will be consumed of the copper nitrate. So this will be the amount consumed of copper nitrate. Okay? So we know how many moles initial we have here. So let's do that calculation again. 3.045 liters times the molarity of copper nitrate, and we get 0.125 moles. This is how much initial copper nitrate we have. Okay, so this is our initial amount of moles of copper nitrate. This is the amount of copper nitrate that we will use in the reaction. So if we subtract this number from this number, we get the number of it being used in the reaction. So let's do that here. Okay, so I wrote out a little bit more legibly here. We have 0.125 moles of copper nitrate initially. We're going to subtract 0.045 moles of copper nitrate. That is what is consumed in the reaction. So we get 0.081 moles of copper nitrate remaining. Or this is unreacted. Or we could say this is the one in excess. So this is how many moles of copper nitrate that are in excess. Usually if the teacher asks the question how much of the excess reagent is left over, they want it in grams. So we have to turn this data into grams of copper nitrate. So let's do that now. Okay, so we have 0.081 moles of copper nitrate that is unreacted or in excess. And to change that into grams, we will multiply it by its molecular weight, 125.55 grams of copper nitrate is equal to 1 mole of copper nitrate. So doing this, we get 10.011 grams of copper nitrate is in excess. Again, if the teacher wants the volume of copper nitrate, well, we can do that also. Since we know moles of copper nitrate, we can turn this value into volume since we know the molarity. So let me show you how to do that. So again, since we know moles of copper nitrate, we can turn that into volume of copper nitrate if the teacher wants to ask volume of excess reagent. Since we know the molarity, then it's 0.866 moles is in the denominator. 1 liter is up here. Let's go ahead and change the liters into milliliters. Usually the teacher wants it also in milliliters. So if we do this calculation, then we have volume in milliliters, which comes out to be 93.5 milliliters of our solution of 0.866 molar of copper nitrate.